Day 19 of doing a LeetCode problem every day until I get a job. All right, guys, we're back at day 19, and I don't see any signs of slowing down anytime soon. Don't forget to like, comment, and subscribe. We're trying to run those subscriptions up. Go ahead, drop them bank emojis in the comments. Or if you have a question you want me to answer, go ahead, drop that in the comments too, and I'll get to it when I can. Probably will be sooner rather than later too. So let's see what we have here today. I have question number 605, can place flowers. The difficulty level is easy, so you know what that means. We're going to keep it simple and easy, and we're not going to make it harder than it has to be. So let's see what the question says today. It says you have a long flower bed in which some of the plots are planted and some are not. However, flowers cannot be planted in adjacent plots. Given an integer array flower bed containing zeros and ones, where 0 means empty and 1 means not empty, an integer n return true if n new flowers can be planted in the flower bed without violating the no adjacent flower rules, and false otherwise. So what this is asking us to do is look at the array of the flower bed array that we have, and find a place where we could plant these flowers without them being adjacent to another flower. So let's look at the examples to see what that means. It says input flower bed is an array of integers containing the numbers 1, 0, 0, 0, 1, and n equals 1. The output is true. The output is true because n equals 1, which means we only have one plant we need to plant, and we could plant that right here at index 2. Because if we planted at index 2, we are not violating the no adjacent flower rule, because the closest plants are index 0 and index 5. So that leaves up index 2 open for a plant. So we could plant right here. We only have one plant to plant. We could put it right here, index 2, and the output is true because we are not violating the no adjacent flower rule. Now let's look at example 2, where we would be violating the no adjacent flower rule, and the output would be false. So in this example, the input flower bed, another array of integers, same integers, 1, 0, 0, 0, 1, this time n equals 2. The output is false because there's only one place for us to plant, which is index 2. But we still have another plant left after we plant that one. So we plant one at index 2, we still have one plant left, but we have nowhere to plant it without violating the no adjacent flower rule, which is why the output is false. If we put it at index 1, that's in between index 0 and 2, and there are already plants there, so that would violate the no adjacent flower rule. Same goes for index 3, because index 4 has a plant and index 2 would have a plant, which would mean we cannot plant right there. It would violate the no adjacent rule, so the output would be false. Now, let's see how we're going to solve this, right? So it's not that hard. It's a little bit of code. It's not a lot of code. It's more than a 2-liner, but it's not that bad, and it's not that hard to understand either once we get into it. So let's get into it. First thing we're going to do, we're going to say if flowerbed.count equals 1 and flowerbed index 0 is, excuse me, flowerbed index 0 is equal to 0, and we're going to say n is equal to 1 or n is equal to 0, we are going to return true. Then we're going to come down here and we're going to declare a variable, and we're going to call that flower b, and we're just going to pass that as an array of integers, and we're going to initialize that with flower bed. Then we're going to come down here, declare another variable, we're going to call that planted, and that is going to be equal to 0, and that is going to count the number of plants that we planted so far. So first thing, since we're dealing with an array and we need to iterate through that array, we're going to start with a for loop and we're going to say for I in 0, up to flower b dot count. Then we're going to say if flower b I and flower b I equals 0 and I is equal to 0. Then what we're going to do, we're going to declare a constant. I'm going to call it right, and that's going to be I plus 1. And what that is going to do is going to let us look to the right to see if there's a plant right there, right? So we're going to do that by, first we're going to say right is equal to I plus 1. Then we're going to come down here and we're going to say if flower be right is equal to 0. So what that is doing is it's checking to see if the index to the right of us is 0 or not. If it is 0, then what we're going to do is we're going to say planted plus equals 1, because that means we can plant right there. Then we're going to say flower b I is equal to 1 because we just planted right there, right? So that's not too hard at all. So then next thing we're going to do is we're going to come down here and we're going to do the same thing for the left side. We're going to say if flower b I is equal to 0 and I is equal to flower b dot count minus 1, what we're going to do is we are going to say let left equal I minus 1. Has to be equal white spaces on both sides of the minus sign, the plus sign, and the equal sign. Because then if it's not, if it was like this, it might think we're saying -1. But no, we want to say -1. That's why. So then we're going to come down here and we're going to say if flower b left is equal to 0. So this is going to let us check to the left and see if there's any plants right there so we don't violate the no adjacent flower rule. We're going to say if it is equal to 0 and there is no plants there, we're going to say planted plus equals 1. And we're going to say flower b I equals 1 because we just planted right there. Then we're going to come down here and this time we're going to check the right and the left, and we're going to do that by saying if flower b I is equal to 0 and I is not equal to 0, we're going to have to check the left and the right. We're going to say let right equal I plus 1. We'll say let left equal I minus 1. Then we're going to come down here and we'll say if flower b left is equal to 0 and flower b right is equal to 0. So what we're doing is we're checking the left and the right to see if it's a 0, because if it is, then you already know what that means. That means we could plant right there. So that means planted is going to be plus equal to 1. And then we're going to say flower b I is equal to 1 because we just put a plant right there. And then we're going to come down here and we are going to say return planted is greater than or equal than n. So this is going to make sure that all the plants in n got planted, because if it's less than n, that means we still have a plant that didn't get planted because it violated the no adjacent rule, and we would return false in that case. So Let's run it and see what happens. Oh, it's accepted first try too. So let's submit it and see what happens. Keep your fingers crossed. And it's accepted first try, no typos or anything. That's what I'm talking about. So that's all for today. Until next time, I'll see you guys tomorrow.